we're going to go over the process known as synthetic division, and this is going to be homework that is based on a lecture that we had. So first question here, we have to divide x cubed plus 3x squared plus 11x plus 9, and this is over x plus 1. Now I want to remark here, the process of synthetic division, we're going to utilize all of these constants here in our polynomial function. And if there's not a number or a constant, if it's just x cubed, we're going to use the value 1. And also notice that we're looking at a polynomial in what's called descending power order. That's going to be important. So we're going to put these constants over here, 1, 3, 11, and 9. And the next part of this is going to be to determine the k value here. So this k value is going to go to the left, and I want to remind people of this. We have plus 1. Now, synthetic division is based on division by x minus k. So we're going to have to divide by this kind of term, x minus k, and you notice here that we have plus 1. So what that means is we have to rewrite this as x minus a negative 1. And so my k value here is going to be simply negative 1. Okay, so if we have x plus 1, just write that as x minus a negative 1. And now this value here is going to be the value that we use. This is going to be that k value. That's simply what we did. Okay, so since k is negative 1 here, we're going to start the synthetic division process. We're going to bring down the 1, goes down here. And remember, what we do here now is we take the negative 1 and multiply it with positive 1 to get negative 1, and this is where we place the answer. We're now going to add here, or in this case subtract. We have 3 minus 1, which is going to give us 2. Okay, we're now going to repeat the process here. What we mean by that is we're going to take the negative 1, we're going to multiply by 2, and we'll get negative 2 now. And at this point again, what we're going to do is we're going to add here. So we can add or we can subtract. This is 11 minus 2, which gives us 9. We're going to now repeat the process here. We'll take negative 1, multiply it with 9, we get negative 9. Now our sum here is going to be 0. Now, what this means here, we're going to put that box again. What this means here, if you guys remember, this means that our remainder here is actually 0. And we're going to also make use of these coefficients that we found. 1, 2, and 9. And we're going to remember that we're going to create now or write this quotient polynomial function. Okay, this quotient. And I think your book will use lowercase q here. So here's our quotient when we divide using synthetic division. Now you go back and you look at the highest power here. This is a third degree polynomial. So these coefficients will correspond to a second degree polynomial. And again, we write this in descending order. And so here's going to be our final answer. The quotient equals x squared plus 2x plus 9. And this is what they want us to find. Our remainder here is in fact 0. So we perform the division. Number 3. 2x to the 4th minus x cubed minus 7x squared plus 7x minus 10. You're going to divide by x minus 2. So notice here, we already have the x minus k form. So in this case here, k is going to be 2. So I'm going to write down the 2 over here. And then I just need my coefficients. 2, 1, negative 7, positive 7, negative 10. 2, negative 1, negative 7, positive 7, and negative 10. We need some space here. So let's just double check that everything is fine here. 2, negative 1, negative 7, positive 7, and negative 10. So let's go through our process now. We're going to bring down the 2. This is how you start that process. We put the 2 down here. So 2 times 2 is going to give us 4. This is where we put the answer. We're now going to add or subtract, meaning negative 1 plus 4 is positive 3. We get to repeat this process now. 2 times 3 gives us 6. Negative 7 plus 6 gives us negative 1. We get to repeat the process. 2 times negative 1 gives us negative 2. 7 minus 2 will give you 5. We get to repeat the process. 2 times 5 gives you positive 10. And when I add here, negative 10 plus 10 will give me 0. So again, in this example, I get a remainder of 0. So we're going to use these values. We know our remainder is 0. This again here is the quotient function, meaning this equals q of x, just like in the last problem. This equaled q of x. So don't forget that we're looking at our coefficients here. So if the highest power here is 4, we're going to actually have a quotient function that has the highest power of 1 less, 3. And we write this as descending powers here. So here's our quotient function. This quotient function will be 2x cubed plus 3x squared minus x plus 5. And don't forget your remainder here is 0. So we did the division like the instructions have asked. And so what this means is that this original fraction here, or rational, is equal to our q of x function. This is what we're talking about. And there's no remainder because we see that the remainder here is 0. This value is 0. Number 5. We have x to the 4th minus 2x squared plus 7x minus 3 over x plus 3. I want to point out an important detail here. They have x to the 4th, x to the 7th, and then x to the first power, but we're missing a term. So when you're missing a term, what you'll do here is insert 0 times that missing term. So here's the third power that's missing. Remember, this is really 0. So that what you really have here is x to the 4th plus 0x cubed minus 2x squared plus 7x minus 3 over x plus 3. Because this is plus, rewrite this as x minus a negative 3. Because again, we're dividing by that term of x minus k. So in this case, k is negative 3. So we're going to put a negative 3 out here. And we're going to actually bring down all our coefficients. There wasn't a 1, so we put 1 there. We got 1, 0, negative 2, positive 7, and negative 3. We're going to bring down the 1. Now, negative 3 times 1 is negative 3. 0 plus negative 3 is negative 3. We get to repeat the process. Negative 3 times negative 3 is positive 9. Negative 2 plus 9 is 7. Negative 3 times 7 is negative 21. 7 minus 21 is negative 14. We repeat the process. Negative 3 times negative 14 is positive 42. Negative 3 plus 42 will be 39. This here is my remainder. Now, we're going to make use of our coefficients here. And let's not forget that we started with a fourth power here. That means our quotient function will be a power 3, 1 less. It is always 1 less. So our quotient function is going to look like this. X cubed minus 3x squared plus 7x minus 14. And here our remainder is actually 39. So if you remember from beginning algebra, where you actually had to divide here these this polynomial here with a linear factor, a linear term, we wrote our answer as a quotient remainder over whatever was doing the dividing. And in this case, what's doing the dividing here is x plus 3. So we're going to put this over x plus 3 here. So your final answer can look like a mixed number. The whole part, which is your polynomial, the remainder part over that x plus 3. I would say at this point, you're good by just doing this. You perform synthetic division by the instructions, but if you wanted to go further and think about what this is, you can. I also want to remark here for the number 7, let's note, we also gave you the division algorithm. So to start a transition, let's remember that if you're ever going to divide by two terms, that numerator term can be written as b times that quotient plus your remainder, where your remainder here can be 0 or it could be not 0. So in this case, if we start to use that division algorithm, we can actually start to describe this whole relationship. that f of x here, the original f, can be described as that x plus 3 term times that quotient plus your remainder here. And if we wrote it all down, and there's a lot to write down, this is the original question here, number 5. If we started to write this, you're going to see x to the 4th minus 2x squared plus 7x minus 3 will equal x plus 3 times the quotient, x cubed minus 3x squared plus 7x minus 14 plus 39. This is by our division algorithm. So as you can see, it's important for us to know a few things. What's the quotient? It's right here. What are we dividing by? It's right here. What's the remainder? It's right here. And if you want to actually give these different colors, x plus 3, the remainder, we can do that, and it actually helps you see the question better, I guess. And so this is writing this in using the format of the division algorithm, but this is the purpose of really using synthetic division so that you can divide and make use of this information. And so we're going to go to number 7 here. X to the 4th minus 1 over x minus 1. Now in this question we have more than one missing term. We have the x cubed term is missing, the x squared term is missing, and the x term is missing. So the question should really look like this. X to the 4th plus 0x cubed plus 0x squared plus 0x minus 1. You're going to divide by x minus 1. X minus k. So in this case, k here is going to be 1. What you're going to go back and do now is take a look at all the coefficients. So if a number is missing, put 1. And now let's look at the details. 1, 0, 0, 0, negative 1. These are all our coefficients that we bring down. We can now start our synthetic division process. Bring down the first term, the first number, and multiply. So 1 times 1 is 1. We put the answer here. 0 plus 1 is also 1. We repeat the process. One times 1 will be 1. 0 plus 1 gives us 1. We repeat the process. 1 times 1 is 1. 0 plus 1 will give us 1. We repeat the process. 1 times 1 is 1. Negative 1 plus 1 will give you a 0 remainder. We're going to now make use of these coefficients. So remember, if your highest power here is a 4, 1 degree less will be x cubed, and write your powers in descending order. Okay, let's double check to make sure everything's okay here. We have 1, 0, 0, 0, negative 1. 1, 1, 1, 1, remainder is 0. Just double checking all the work. Here's the error. There it is, descending order. Okay, got it. Here's our quotient. Our quotient is x cubed plus x squared plus x plus 1. And you have a 0 remainder. So if you wanted to write it as a mixed number, QRD, you can't. You're looking at the answer right now because your remainder is 0. You're done. So this equals that quotient here. Number 9. So if we look at number 9 here on the homework, what they want us to do is use synthetic division to express your function of the form. They want f of x to be written as x minus k, q of x, plus that remainder. In other words here, they want us to write this using the division algorithm. So what we need to determine again is a quotient and a remainder. Now we've been doing that with all these other problems here. So here's question 9. They're saying your function here is going to be 2x cubed plus x squared plus x minus 8, and k is going to equal negative 1. So, by synthetic division, we got negative 1 here. 2, we're missing a term. 1, missing a term. 1, negative 8. So you have 2, 1, 1, negative 8. Now, I want to rephrase this. We weren't missing a term here. We were missing coefficients. Now there's a difference. Missing coefficients means we just multiply 1 to that term, and that's what we did. So we're bringing down these constants. We're using synthetic division again. So bring down the 2. Multiply negative 1 and 2. That gives you negative 2. Add or subtract here, and you get 1 minus 2 is negative 1. You're just going to repeat the process now. Negative 1 times negative 1 is positive 1. 1 plus 1 gives you 2. So you repeat the process. Negative 1 times 2 gives you negative 2. Negative 8 plus negative 2 gives you a negative 10 here. This is my remainder. So I'm going to use these coefficients again. And remember, my polynomial will always be 1 degree less than the given function. So 1 degree less than 3 would be 2, so this will be x squared and x. This is my quotient. We now have to write this using this format here. So let's write it this way. That original function, f, that polynomial, will be we divided by don't forget we have to use this information here. We really divided by x minus k times this q of x plus our remainder. Now we found here our quotient. So we can say this quotient here is going to be 2x squared minus x plus 2. However, we also have to make use of our remainder here. And here's the remainder. So that remainder here is going to be negative 10. So here's what this looks like altogether. We have to also recall that the k value here is negative 1. So if I plug in this negative 1 for k here, notice what we get. This term here will be x minus a negative 1, which really means x plus 1. So it's important for us to remember this k value over here. It's negative 1. So altogether here, as we write our answer, that function equals x plus 1, because k is negative 1, times 2x squared minus x plus 2 minus 10. This is how they want us to write our answer. So this is synthetic division, and all the details that were taken from the prior set of questions are used here in a slightly different way. We have to always remember if k is negative here, that means what we're really dividing by is actually k plus 1. That's going to be our division. And so yes, it's opposite values if you want to look at it that way. And that term here goes right down here. Okay. Number 10. Actually, that brings us to 11. The original function here now is going to be 4x to the 4th power minus 3x cubed minus 20x squared minus x minus 5, and k here equals positive 3. So let's double check to see if this is really what we have. Okay. So with synthetic division again, k is positive 3. We have to identify the terms. 4, negative 3, negative 20, negative 1, and negative 5. These are the coefficients of my terms. So when I bring down these coefficients, we have 4, negative 3, negative 20, negative 1, and negative 5. These are my coefficients. So we're going to bring down the 4, and we're going to note that 3 times 4 will give you 12. Negative 3 plus 12 gives you 9, and we repeat the process. 3 times 4, 3 times 9 will give you 27. Negative 20 plus 7, or 27, gives you 7 here. I'm already giving the answers. Okay, repeat the process. 3 times 7 will give you 21. Negative 1 plus 21 gives you 20. We're going to repeat the process. 3 times 20 gives you 60. Negative 5 plus 60 gives you 55. This here is your remainder. We're going to make use again here of these coefficients. So we go back to the original question here, or the original function, and that highest power is 4. So that means we're going to have 1 degree less. Here's our quotient function. So writing this in the format of the division algorithm, f of x equals x minus k, q of x plus r, we just have to plug everything in. Let's take a look. K is 3. So here I plug a 3 in. My quotient function is 4x cubed plus 9x squared plus 7x plus 20, because we found that. That's what this is here. And then don't forget our remainder here of 55 goes right here. So here's really what this answer is. Here's what they're looking for. And so we can erase all the colors. And here's your final answer here. Number 13. F of x is x to the 4th minus 3x plus 5, and k is 1 here. I want to point out that when you look at the powers here, you see a 4th power and then a 1st power, so there's a couple of terms missing. The whole terms are missing, not the coefficients. 0x cubed, 0x squared, we put the 0 as a coefficient for these missing terms, and the 1st power is there, so here's what we really have as a function. X to the 4th. Looks like we lost some things here. We're going to bring them back. Plus 0x cubed plus 0x squared. Don't forget this is going to be minus 3x plus 5, and then k here is 1. So using synthetic division, we have our 1 down here. We're going to write down all the terms now, meaning the coefficients of the terms. 1, 0, 0, negative 3, positive 5. 1, 0, 0, negative 3, positive 5. Start by bringing down 1, and you will have 1 times 1, which is 1. Add 0 and 1, and you get 1. Repeat the process. 1 times 1 is 1. 0 plus 1 will give you 1 again. Just repeat your process. 1 times 1 is 1. Negative 3 plus 1 gives you negative 2. Repeat your process. 1 times negative 2 is negative 2. And we get 5 minus 2 gives you what? 3. So in this case, again, my remainder here is actually 3. We're going to make use of the coefficients again. Here's our q of x. So if our original function, polynomial function, has the degree of 4, 1 less makes this x cubed, x squared, and x. So they want us to write our answer as f of x equals x minus k times the quotient function plus our remainder. So let's go back and remember what k actually is again. K is the value 1. That goes right here. So this will equal x minus 1. This is my function. My quotient function is x cubed plus x squared plus x minus 2. This is what we just found, right in here. Our remainder here is going to be plus 3. This is what we also just found. So we're simply making use of all these coefficients with synthetic division, and we're using this division algorithm. This is the format they want us to write our answer in. Okay, number 15, let's remember the remainder theorem. Since f of x equals x minus k times q of x plus r here. Let's remember this remainder theorem because we're going to use this for the next set of problems here. What we said in the remainder theorem was the following. If x equals k, then f of k will be, let's plug in k here. This is what they're asking us to really do. Let me find the appropriate color here. If I plug in k for x, wherever there's an x, I plug in k. I'll get k minus k, q of k, plus r. So what this means is f of k will equal my remainder. Because what I have here, k minus k, this value here is going to be 0. So we're going to use this information here to find the remainder. And so here's what they're going to say, and here's what we want to notice here. Let's note at this point. If the remainder here is 0, then we know that f of k equals 0. And let's recall what this means. This means then k is a 0 of the function f. So when our remainder is actually 0, this value here, we have a very special situation. That situation is saying that k is known as a 0 of the function. And this is actually more than a note. This is actually a definition of a 0. So we're going to use this remainder theorem to find zeros of the function. So the next question here, notice what they say. This is 13. We have now 15 here. The instructions for 15 would be they're going to give us a function f of x. And that's going to be x squared plus 2x minus 8. And they're going to say k here is 2. Here's the instructions. For each function, use the remainder theorem and synthetic division to determine the value of f of k. So we're going to use synthetic division to find f of k. Remember, f of k is simply my remainder. Also, indicate whether f of k is actually 0 for this polynomial function. If it is 0, then we know that this is a 0 of the function. It's also known as a root, and graphically it'll be the x-intercept. Those are all the ideas that we discussed. So we're going to use this criteria here. Let's use synthetic division. Let's go through that problem here. K is 2. They gave that to us. And when we go back to the original function, the polynomial function, we need the coefficients. So everything is just like what we did before. So as we go through synthetic division for this question, we're going to bring down the 1. Remember, you have the following. You have 2 times 1, which will give you 2. We're now going to add here. 2 plus 2 gives you 4. We get to repeat the process here. So by this process, we take 2 times 4, and that's going to give me 8. So negative 8 plus 8 gives me a 0. So here's what this means for us. What we have seen here, what this says is that f of 2 equals 0. Remember, this is my remainder. We've been saying that. So when the remainder is actually 0, that's a special situation. We say 2 is a 0 of the polynomial function f. So what are they saying in this instruction? Use synthetic division to determine the value of f of k. We did. F of 2 here is going to be 0, so this is what you guys write down. This is simply the answer to the question. But more than that, what that means is the number 2 inside here. This number 2. This is called the 0 of the function. We also said, by the way, and we'll write this down too, so let's draw our conclusion here. 2 is a 0 of our function. 2 is a root of the function. And we have an x-intercept at 2. So this is our conclusion here. But to the answer to the question, this is what you're doing, and you're notating this situation, and that's pretty much what they're asking you, but we gave you extra information to use in the future. And that's how we use synthetic division to answer all these questions here. Number 17, you have a function x cubed minus 3x squared plus 4x minus 4. And again, they want to use k as 2. So they want us to determine what f of 2 is. So we're going to use synthetic division. 2 don't forget to copy down the coefficients. 1, negative 3, positive 4, negative 4. We're going to start by bringing down the 1. And so 2 times 1 will give you 2. Negative 3 plus 2 is negative 1. Repeat the process. 2 times negative 1 is negative 2. 4 minus 2 is positive 2. Repeat the process. 2 times 2 will give you 4. Negative 4 plus 4 again happens to be 0. So again, this is our remainder. And remember, by the remainder theorem says that f of k is r. Or in this case, f of 2 equals 0 again. And again, we can say 2 is a 0 of the polynomial function. 2 is a root of the polynomial function. Or graphically, you have an x-intercept at, really, 2. So the answer to the questions are going to be right here, these two. This is what they're looking for. Number 19. F of x is 2x cubed minus 6x squared minus 9x plus 4. They want to see whether k equals 1. Well, they want us to find the value of f of k, or f of 1. So we want to find what f of 1 equals, and we have to use synthetic division. So since k is 1, it's out here. Let's copy down our coefficients. 2, negative 6, negative 9, positive 4. So again, we're going to start by bringing the number down here. Let's do this process. 1 times 2 gives you 2. Negative 6 plus 2 is negative 4. We repeat the process. 1 times negative 4 gives you negative 4. Negative 9 plus negative 4 is negative 13. We repeat the process. 1 times negative 13 is negative 13. 4 plus negative 13 will give you negative 9. Okay. This is what this means. F of 1 is negative 9 because, again, f of k equals the remainder. So here's our answer. I also want to point out here, for this particular remainder, negative 9 is not 0. So we can answer further and say the following, that 1 is not a 0 of my polynomial function. So this is another answer they want us to give. Similarly, you can say 1 is not a root of the function f, and it's also not an x-intercept. So 1 is not an x-intercept as well. So they didn't ask us those questions. We did mention this in class. I just want to point that out because in the future will be soon, we will be using this information. This is how we answer 19. (21) f of x is 4x to the 4th plus x squared plus 17x plus 3, and k here is negative 3/2. They want us to find the value of the function at negative 3/2 using synthetic division. So let's bring down our coefficients of the terms, 4. And let's go back a bit. We notice a cube term is missing. So we're going to have to insert 0x cubed. That's my next coefficient. For the x squared term, we put the 1. For the x term, we got positive 17 and a positive 3. So the coefficients will be 4, 0, 1, 17, and 3. So here's what you're going to do. Bring down the first term, and again, go through your process of synthetic division. Negative 3/2 times 4. If you have to do some scratch work, go ahead and do so. Negative 3/2 times 4 is really going to be negative 6. That goes up here. So do your arithmetic. 0 plus negative 6 is going to be negative 6. So we're going to have to repeat the process. Negative 3/2 times a negative 6. So we have negative 3 halves times negative 6. A negative times a negative is a positive, so it's really 3 halves times 6. And again, 2 goes into 6 3 times, so 3 times 3 is going to give us 9. And that goes up here. Doing our arithmetic. 1 plus 9 is going to give you 10. So we get to repeat the process now. Negative 3 halves times 10. Negative 3 halves times 10. 2 goes into 10 5 times, and negative 3 times 5 is negative 15. Do your arithmetic. 17 minus 15 will give you 2. We get to repeat the process. Negative 3 halves times 2 is going to give us negative 3. Because the 2's cancel. Now, when I add 3 with negative 3, the answer will be 0. So what we found here, if we just clean this up a bit, remember by the remainder theorem, f of k equals that remainder, we found f of negative 3 halves is 0. Because this again is my remainder. So in conclusion, this is one answer they want us to get. Negative 3 halves is called a 0 of our function. And that's what they want us to know. So this is question number 21. (23) The function they give us is 5x to the 4th plus 2x cubed minus x plus 3, and k here is positive 2/5. Okay. Now, when we notice here, as we go through this, let's notice that it's missing an x squared term. So we're going to have to put here 0x squared. So let's copy down the coefficients now. Five, 2, 0. What's missing here is a number there. This will be negative 1 and positive 3. 5, 2, 0, negative 1, and positive 3. So let's perform synthetic division. Bring down the 5. Now, 2/5 times 5 will be 2. Because the 5's cancel. 2 plus 2 is 4. Repeat the process. 2/5 times 4. Do the arithmetic. 2/5 times 4 now is going to give us 8/5. This is where we put our fraction. We're now going to add 0 plus 8/5, and we're going to get 8/5 here. So this is the arithmetic. When you repeat the process now, 2/5 times 8/5. we have to see what this is. 2/5 times 8/5. How do we multiply? Horizontally across, we get 16 over 25. That answer goes here. Okay. We're going to repeat the process. Sorry, we have one left arithmetic question to answer. -1 plus 16 over 25 here. Now don't forget to change this to 25 over 25. We can now add -25 plus 16 is going to give us -9 over 25. So that goes down here. Okay, now we get to repeat the process. 2/5 times -9 over 25. Again, multiply horizontally across, and we get -18 over 125. That goes over here. We now have to add these two numbers, or subtract, however you want to look at it. And I'm going to erase some of the work I have here. You can always go back in the video, because the arithmetic we have to do now will be 3 minus 18 over 125. Now, remember, you want the same denominator here. So we multiply the top by 125 and the bottom by 125 here, so that we have fractions that are like. Now 3 times 125 gives you 375 over 125 minus 18 over 125. So we have to know, what is 375 minus 18? So the answer is going to be 357 over 125. And we could put this here. Now, you might want to think about reducing this fraction, because every answer that we give as a fraction must be reduced to lowest terms. However, notice the denominator is really, when we break that down into the product of its primes, that's 5 to the third power. And the prime 5 does not go into the number 357. 5 doesn't go into 357. Okay, because 125 is written as 5 to the third power. So it looks like this is reduced, and this is our answer. So here's what we're going to say. F of 2/5 is 357 over 125. Remember, f of k equals the remainder. This is our remainder that we've been finding here. And because the remainder is not 0, we can also conclude that 2/5 is not a 0 of our function. And that's what they want to know. So this is the answer to 23. Our function is x cubed minus 5x squared plus 3x plus 1, and they didn't give us a k value here. They gave us the x minus k term. And so what they're going to say now for question number 25 is, use synthetic division to determine whether x minus k is a factor for the polynomial function. So the question is going to be, is x minus k a factor? Now, what does that mean, to really be a factor? that means here your remainder is actually going to be 0. Okay, because they want us to write, again, f of x equals x minus k times q of x, where now you don't have a remainder here because that remainder is going to be 0. Okay, this is plus 0. It's not even there. It's like saying we took the original function and we factored it. So we need to find if we get a remainder of 0 here, and that will answer our question. So is x minus k a factor? Well, let's see if the remainder is 0. But notice what they gave us here. They didn't give us the k value. We're going to have to find the k value. So if you have x minus 1, the k value here then is going to be positive 1. So we put our 1 here, and we have to obtain all the coefficients for the polynomial function. One, -5, 3, and 1. One, -5, 3, and 1. So we're going to do our synthetic division process again. So we start by bringing down the 1, and then 1 times 1 will be 1. -5 plus 1 gives you -4. We repeat the process. 1 times -4 gives you -4. 3 minus 4 gives you -1. Again, we repeat the process. 1 times -1 gives you -1. And then -1 plus 1 will give you that 0. So here's our conclusion here. Essentially, they're asking us, is the remainder equal to 0? And the answer is what? Absolutely yes. So what this means here is, here's our conclusion. X minus 1 is a factor. So we can write it this way. X minus 1 is a factor. However, let's be a little bit more specific here. Let's write down what this means. Because, don't forget, we can make use of these coefficients. This is our quotient function. And 1 degree less than 3 is 2. X squared x minus 1. So altogether, we can write our original function, f of x, is x minus 1 times the quotient, x squared minus 4x minus 1. This is what they want you to observe. That in a sense, you factored the original polynomial function. And this is using all the information, and this is what they're giving you here. This is why they care about finding the remainder being 0, because that means you essentially factor the polynomial function. Here is the answer. Number 27. Your function is 2x to the 4th plus 5x cubed minus 8x squared plus 3x plus 13. You now have an x plus 1 term. So they want to know, is this x plus 1 term a factor? Okay, it's going to be a factor when the remainder is 0. But don't forget, we have to write this as x minus a -1 because we need the value for k. This is the k value now. Let's make sure we have our coefficients. 2, 5, negative 8, positive 3, 13. And we perform synthetic division. Bring down the 2. Negative 1 times 2 is negative 2. 5 minus 2 is positive 3. We repeat the process. Negative 1 times 3 will give us negative 3. Negative 8 minus 3 is negative 11. We repeat the process. Negative 1 times negative 11 is positive 11. 3 plus 11 gives you 14. We repeat the process. Negative 1 times 14 gives you negative 14. And 3 minus 14 gives you negative 1. Remember, this is our remainder, and this remainder is not 0. So when do you have a factor again? When the remainder equals 0. We're looking at this here. So here's what we can conclude here. Here's what we say. That the x plus 1, here's what they want us to check. That term is not a factor of your original polynomial function f. That's what they want us to check. Simply because our remainder value here is not equal to 0. This is a remainder. It's negative 1. (29) f of x is minus x cubed plus 3x minus 2. We have x plus 2. So they want us to know or check to see whether x plus 2 is a factor. Now remember, we write this as x minus a minus 2. And so, since we're checking x minus k here, we know that k will be negative 2. So I bring down the negative 2 here. Let's also notice our coefficients. We got negative 1, but we also notice here that we have some terms that are missing, or I should say a term. The x squared term is missing. And so we're going to have to put a 0x squared. So when we notate the coefficients now, negative 1, 0, 3, negative 2, we are now ready to do sign analysis. So bring down your negative 1. Negative 2 times negative 1 is positive 2. 0 plus 2 is 2. Repeat the process. Negative 2 times 2 will give you negative 4. 3 plus negative 4 is negative 1. Repeat the process. Negative 2 times negative 1 is positive 2. Negative 2 plus 2 is 0. So here, our remainder is 0. So here's the conclusion. We can say x plus 2 is a factor. Because again, what that means is our function f can be written as x plus 2 times that quotient plus that 0 remainder. Well, that 0 is not even there, or you can say if I add 0, this thing equals itself. So the function here will be x plus 2 let's remember, we're going to make use of these coefficients. Since your highest power here was 3, that makes this x squared, x, and then your constant. So we have here negative x squared plus 2x minus 1, and you have factored. You factored the original polynomial function. This function over here. This is the f they're talking about. So the answer to the question is that x plus 2 is a factor. However, we do want to know what that means. What that means is that we factored our f, and this is what you get when you factor. (31). Our function here is 2x to the fourth plus 5x cubed minus 2x squared plus 5x plus 6. They want to know whether x plus 3 is a factor. So again, x minus a minus 3. We have to determine the k value. So in this case, k is going to be negative 3. Let's check our coefficients. 2, 5, negative 2, 5, and 6. We're going to have to do synthetic division. We start by bringing down the first term, or the first number, 2. Negative 3 times 2 is negative 6. 5 minus 6 is negative 1. We repeat the process. Negative 3 times negative 1 is positive 3. Negative 2 plus 3 is positive 1. We repeat the process. Negative 3 times 1 will give you negative 3. 5 minus 3 is 2. We repeat the process. Negative 3 times 2 will give you negative 6. And then 6 minus 6 is going to be 0. So that remainder here is 0. What we've shown here is that x plus 3 is a factor. Now let's write down what this means. This is our quotient function. Since the highest power here is 4, that means x cubed, x squared, x, that those are the coefficients for your for your quotient function. And to be a factor, what this means is your original function f is written as x plus 3 times 2x cubed minus x squared plus x plus 2, where you have a 0 remainder here. This is what you have to do for 31. Now, the next group of questions in synthetic division here. Okay, number 33. Our function here is x cubed minus 2x squared minus 5x plus 6, and they gave us a 0 here. So for the next set of questions here, they want to say factor each polynomial function where 1 0 is given. So here we have 1 0. Let's write down what this means. This means f of 3 equals 0 because they're saying this is my 0. This is the k value that they gave us. So f of 3 equals 0. They want us to determine, and here's the question. All other zeros. So we have to find all the other zeros. Now, in order to do that, what we really need to do is we need our quotient function, q of x. That's going to help us locate the other zeros. Let me remind you. F of x is q of x. Let's go back. X minus 3 times q of x. Because remember, 3 is a 0, k is 3. So this is where we got the x minus 3. And you have a 0 remainder here. So the idea here is going to now be find that q function, and when we find that function, that quotient, we're going to find the rest of the zeros. Let me show you what I'm talking about. Since we already know that f of 3 is 0, by synthetic division here, put down the k value. 3. Let's determine the coefficients. 1, -2, -5, and 6. So we have 1, -2, -5, and 6. Because we know 3 is a 0, we're going to end up with 0 down here. So let's double check here. By the process, bring down 1. And now 3 times 1 will give us 3. -2 plus 3 gives us 1. We repeat the process. 3 times 1 gives you 3. -5 plus 3 will give you -2. Repeat the process. 3 times -2 gives you -6. So that when I add these values, I'll get 0. Here's my 0 remainder here. So sure enough, 3 is a root. Now, we're going to make use of the coefficients here. Here's how we use this. Go back. Remember here that your highest power there is 3. So for our quotient function, this will be x squared. This will be x. And so what this really means is, altogether, the original function can be described as x minus 3 times that quotient function. Don't forget, we got the x minus 3 here. K is 3. So the factor here, if k is 3 here, is going to be x minus 3. So we got x minus 3 here times that q. Well, what is that quotient? That function's going to be x squared. Let's go back and let's erase this. X squared plus x minus 2. So here's that quotient function. Now remember, they want us to find the other zeros. So let me write that down. What are the other zeros? Well, you can find the other zeros simply by doing the following. Okay, you're going to set your original function equals 0, which means x minus 3 times x squared plus x minus 2 will equal 0. And so what you want to now do here is factor the quotient function. This quotient function is factorable. So you want to factor this. And you could use your procedure for factoring here, if you guys remember. The product is -2, and your sum is +1. So you need two numbers multiplied together is -2, but when added is +1. You can say 2, 1, make the 1 negative, because 2 times -1 is -2, and 2 minus 1 is +1. So these are the numbers. So you have x plus 2 here, x minus 1. Don't forget, 2 goes here, -1 goes here. You have factored this trinomial. So altogether, you have x minus 3 times x plus 2 times x minus 1 here, and that equals 0. Since we're finding the zeros, use the zero product rule. X minus 3 is 0, x plus 2 is 0, and x minus 1 is 0. So notice if I add 3 to both sides over here, I'll get x is 3. That is one of the zeros. We already knew that. Subtract 2, we'll get x is -2. This is another 0. Add 1 to both sides, and you end up getting the last 0. This is x is 1. So this is how we find all the zeros. These are the values of x that make that polynomial function equal to 0. This is what we just found. So here's our answers. 3, -2, and 1. These are all our zeros. So you can write it down that way if you like, or you could just leave it as is. But this is the process of finding the other zeros when you're only given one zero. So reduce your polynomial function from a third degree to a second degree and essentially find the zeros for that quotient function, this q here. This is what we did. We found q, and we found the zeros for q, so altogether we have all the zeros. So we're just going to use this process to finish off the rest of the questions. So we have 35 now. F of x is x cubed minus 2x squared minus 13x minus 10, and they give us 1, 0. So this k value here is +5 again, or not again, but it's +5. So since it's a 0, we know that f of 5 equals 0. This we also know is our remainder. So we still need the quotient. And that's what we have to find. Synthetic division will give us that quotient. We just need all the terms. These coefficients, -1, -2, -13, and -10. 1, -2, -13, -10. Bring down the 1. 5 times 1 will give you 5. -2 plus 5 will give you 3. You're using your synthetic division process. So repeat your steps. 5 times 3 gives you 15. -13 plus 15 will give you 2. Repeat the steps. 5 times 2 gives you 10, negative 10 plus 10. Sure enough, gave us that 0, but we already knew that, because that's the information that was given. It's given right here. What we really want is these coefficients for our quotient function. So what this means is the original function again is described as x minus k times that q of x. So the original function is going to be x minus 5. Let's find the quotient. Don't forget, power 2. We need 1 degree less, x squared, x. So our quotient function will be now x squared plus 3x plus 2. If k is 5, right up here, x minus k, that's simply x minus 5. That's the linear factor. What we have to do now here is factor this trinomial, and we'll find the other zeros. So use your procedure. The product has to be 2, and your sum has to be 3. So I need two numbers multiplied together, which is positive 2, but when added is positive 3. 2 times 1 is 2. 2 plus 1 is 3. Okay, here's what this is. X plus 2, x plus 1. Remember, these are the values. So altogether, our function is x minus 5 times x plus 2 times x plus 1. Remember, when we set the function equal to 0, this will give us all of our zeros. We have to solve that for x. So that means we have x minus 5 times x plus 2 times x plus 1 is 0. Use your zero product rule. X minus 5 is 0. X plus 2 is 0. And x plus 1 is 0. This is the zero product rule. Again, meaning when you multiply all three terms together and it equals 0, it simply means either of those terms are 0, or a combination of those terms were 0. So add your 5 here. X equals 5 is called a 0. Well, we already knew that. Subtract your 2. X is negative 2 is another 0. Subtract your 1. X is negative 1 is the last 0. So we could label these. These are the zeros of the function, also called roots of the function. They're also the x-intercepts. This is what they want us to do. 37. Our function x cubed plus 6x squared minus x minus 30. Where negative 3 is given, they're telling us that this is a 0. So that means f of negative 3 equals 0. Okay, again, to find the other zeros, we need the quotient function. That's where sign analysis comes in. Since k is negative 3, we need our coefficients. 1, positive 6, negative 1, negative 30. 1, 6, negative 1, negative 30. So we're going to bring down the 1. Negative 3 times 1 is negative 3. 6 minus 3 is 3. You repeat your process. Negative 3 times 3 will give you negative 9. Negative 1 plus negative 9 is negative 10. You repeat the process. Negative 3 times negative 10 is positive 30. And negative 30 plus positive 30, sure enough, does give you 0. Well, we already knew that. We knew the remainder was 0. Or we knew f of negative 3 was equal to 0, because that's what they gave us up here. So let's remember what this meant. This means my function can be described as x minus k times the quotient function, where my quotient function is right here. Don't forget, if my highest power is 3, 1 degree less is x squared, and then that x. So I know the quotient function. That's going to go right here. X squared plus 3x minus 10. I also know the value of k. K is negative 3, because they gave it to us as negative 3. So let's write this all together. The original function can be described as x minus a minus 3, x squared plus 3x minus 10. And don't forget, minus the minus actually makes this a plus. Here's what we're looking at. So we need to find the other zeros. Now, we could do this another way, but let me just go with how we've been doing this, right? To find the zeros, you set the function equal to 0 and you solve for x. What that means here is x plus 3 times x squared plus 3x minus 10 is 0. So if you're kind of awake with this, notice that we really just need to actually factor this and use the zero product rule. So let's factor and use your favorite technique, right? Product is negative 10. Sum is 3. I need two numbers multiplied together is negative 10, but when added is positive 3. We can say 5 and 2 and make the 2 negative. And so 5 times negative 2 is negative 10. 5 minus 2 is positive 3. So we're going to get x plus 5 times x minus 2 again, because we're going to use these values here and here. But all together, you have x plus 3 times x plus 5 times x minus 2 equals 0. Again, at this point, you could use the zero product rule, because again, you have a product of 3 terms equal to 0, so we can set every term equal to 0 here. And we have to now solve for x. Subtract 3. X is negative 3 is a 0. Subtract your 5. X is negative 5 is a 0. Add your 2. X is 2 is a 0. These are all zeros of your function. Here's your answer. This is question number 37. That leaves us to 39. F of x is 6x cubed plus 17x squared minus 31x minus 12, and they're going to say that negative 4 here is a 0. This is the k value. So again, we essentially need the quotient function. Negative 4. Let's find the coefficients. 6, 17, negative 31, and negative 12. So you're going to bring down your 6 here again. Negative 4 times positive 6 will give you negative 24. 17 minus 24 gives you negative 7. And you repeat your process. Negative 4 times negative 7 gives you 28. Negative 31 plus 28 gives you negative 3. You just repeat your process. Negative 4 times negative 3 is positive 12, and sure enough, like we knew, my remainder was 0. But we knew that because they told us in the first place. When we use negative 4, we'll get that 0 remainder. So as we've been notating here, the original function here can be described as x minus k times q of x, where k is negative 4. And q of x will be, let's go back, 1 degree less, see that here, 1 degree less. Okay, let's try that again. 1 degree less than 3 makes that x squared and an x. So our quotient function is going to be 6x squared minus 7x minus 3. Okay. F of x is x minus a negative 4 times 6x squared minus 7x minus 3. So minus the minus makes this a plus. Okay. So now at this point, we're going to have to factor this trinomial because we need the other zeros. So again, you use your favorite factoring technique, where here your product again is going to be negative 18, and the sum is negative 7. So I need two numbers multiplied together is negative 18, but when added is negative 7. So let's try 9, 2. That'll be a negative 9, because negative 9 times positive 2 is negative 18. Negative 9 plus 2 is negative 7. Okay. X minus 9 and x plus 2. But if you're awake, that's a 6. So remember, we have to divide both of those terms by that 6. Now we don't get a nice integer number. We get these rationals, we get these fractions, so we have to simplify our fractions. So this is x minus 3 goes into 9 3 times, and 3 goes into 6 twice. X plus, simplify to 6, this will be 1/3. And don't forget, we have to bring this 2 over. Let's do this here. Don't forget this 2. And this 3, we have to bring them up over here for both of these. So we get 2x minus 3, 3x plus 1. All right, let's put this together here. Don't forget, we have an x plus 4 here. We got these other two terms. So our function will be equal to x plus 4 times 2x minus 3 times 3x plus 1. Here's our function. And of course, we set this function equal to 0. So that means we have x plus 4 times 2x minus 3 times 3x plus 1 equals 0. And we use our zero product rule. Because remember, we got a product of 3 terms and it equals 0. So we're going to set every one of those terms equal to 0. And we solve for x. X is negative 4. X is 3/2. And x is negative 1/3 here. Let's make sure we write that a little clearer here. So all of these numbers here are roots. We knew the negative 4 was a root or a 0. Right? This is what they gave us to begin with. There you go. Negative 4 was a 0. So the other zeros will be 3/2 and negative 1/3. And that's our homework.